Hello everyone. So as part of the learning task in data structures and algorithms, uh, this is a review about what the stack is and about implementing the stack data structure in a Python program. So at first, let's talk about what is a stack. So a stack is a data structure with which it follows the principle LIFO, which means last in, first out. And then the stack has two main functions or operations, which is to push or to insert, then pop, which means to remove. What do we mean by push is, let's take this for example. If we want to push 8 into this stack, we can only do that at the top of the stack, not at the not at the between stacks, between each elements, and at the start. If we want to pop an element, we can only do that also at the top, not between, and not at the start. Let's proceed to the program. So we are tasked to design a Python program that will implement a stack abstract data structure using array implementation. The program should determine the height of each stack and at which height that three stacks are equal. It will then ask the user for the elements of the stack. The inputs are separated by space, and once the enter key is pressed, the next prompt will be displayed for you. So the way this works is when the stacks can be equal at a certain height, it will then pop elements on each stack so that all of them are equal at that height. If the stacks are not equal at a given height, it will prompt a message that the stacks will never be equal. It's supposed to loops until the user chooses to not continue. So let's go on to the code. Here's the code. So a brief description about it is you need to import dictionaries so that it will store the stack and also its sum or the sum of all of its elements. Then have this function to solve, which solve for the sum of the elements inside the stack. Then it will return that sum as its height. So the next is this function that will prompt the user to input elements inside the stack. Then the function to pop elements until all stacks are equal, and the function that will ask the user if they want to end on that. So here's the program. So while true, this means these are the loops until the user chooses to not to. If the max height is never be equal, it will print that stacks will never equal. This one, if the max height can be equal at a certain height, it will then call the pop function, which is this one. Now let's try to run it. So let's take an example from the sample run. So there you go. It will then display the total sum, and then it will display the max height of each stack, where it will be equal, and then it will pop each stack until the desired height is reached. So 2 on 1 1 is 5, 2 and 2 1 is also 5, 4 and 1 is also 5. Then let's try another one. So, yes. So elements of stock 1, 3, 2, 1, 1. There we go. The stock size will never be equal. This will never be equal. Let's try another one. One, four, four, five, so this one. So another example. So the letters that amongst height are all equal at height 7. Then it proceeded to count elements 3 and 2. So we get 2 plus 4 is 6 plus 1 is 7. Then same goes to the other stocks. And the last one is another example from me. So let's try 5, 5, 10, 1, 2, 3, 10. That's an example. That's from an example. So the box height of elements across all stocks is 10, and then pop the numbers 32 and 10. This one it pops number 15, 2 and 1. This one it pops the number 10. Let's continue. So another example. 1, 2, 3, 5, 4, 7. The stock price will never be equal. And when the user wants to end the program, just need to. That's all from me